Good day, everyone. I am Mr. Destiny DK, and I am a science tutor. And this is just to help people who are disadvantaged about how to get their practical apparatus and how to get the results. Okay, probably their practical apparatus they are not working very fine, and then they want an alternative way of getting accurate results. Then my videos are all about it. Before I go into what I have for you today, I would like to talk about something. This is me helping out, okay? This is me trying to make sure that I give out to the to students out there, okay? I've been doing this for years, and it has been working, all right? But for only my students. I don't do it for any other person. I don't do it for other students out there. I don't post it online, all right? I decided to come out this time around to post it online because I feel there are so many people that need it out there. By all means, I am not forcing anybody's hands. If you feel that my way, my method are not okay, then don't use it. If you are a teacher, don't use it also. All right? You don't need to tell your students that this is it. Okay? If you are not convinced about the method, you just go ahead and use your own method. Okay? Like I said before, I have not seen the question. Okay? It's just an intelligent guess. It's an intelligent guess that has always worked. Okay? So please, I do see in the comment section, and I see people commenting different kinds of things. While I cannot avoid that scenario, okay, because people will always want to come and, they feel like when they want to promote themselves, they can only promote themselves by bringing other people down. Okay. I did mention in one of my videos out there before that the question is subject to the questions that is coming out. Okay, all right. No matter how accurate my predictions might be, it will still be subject to what? To the examination questions. Okay. They might use different values, different parameters, and all that, different alphabets to represent, different symbols to represent parameters, to represent physical quantities. All right? It doesn't matter. Okay? All you just have to do is what is what and what is what. And if by far most, by any means, okay, because there's always a first time for everything, okay? If by any means they change the view, okay, of the questions, they change the way that such that what comes out is not actually what I predicted. Then you have to conduct the experiment. Okay, like for example, in this experiment of this year, what they are supposed to do is vary the length. All right, vary the length and then allow the rule to oscillate. Okay. However, in this year they introduce mass. They introduce different masses. Now, if the oscillating body is not elastic, if the oscillating body is not like a spiral spring that we oscillate, okay, while being extended, you extend it and allow it to oscillate. Okay, if it is not an elastic material, it's there is no way mass will affect the oscillation. Okay, do you understand? There is no way, according to O-level physics, that mass, the mass of the of bodies, okay, will affect the the period of oscillation, okay? All right? Unless there is a spring balance. And the one we are doing in this year's practical is not a spring balance, okay? It is not a spring balance. So mass is not supposed to affect it, okay? Okay, to the best of my knowledge too. Mass is not supposed to affect it, all right? And that is why we brought out that formula for the other one, T equal to 2 pi root L over G. All right, so what they're supposed to do is to vary the length and what, and oscillate it. Are you getting it? Even no matter the mass they put there, okay, once they keep that mass constant, it doesn't matter, okay? Do you understand? Only length can affect it. But the only issue here now is if they keep the length constant and now they are varying the mass, okay, then we are talking about a bifilar oscillation. And in that case, there are so many relationships that connect the mass to the period, okay? All right, so because I am not sure of that, I can't give you any of those, and that's why I didn't release any video on that. Okay, so when they are varying mass, when mass is now introduced to the variable, please, I will advise everybody to conduct the experiments and get their results. The only thing is that as you are conducting the experiment, you will make sure that you are as accurate as possible, because my method of manipulations is to eliminate any margin for error. Okay, because you are marked according to how accurate your results are. Okay, so try as much as possible. When they are varying the mass, they say put 10 gram, replace it with what, 20 gram, add some mass. What they are varying, if what they are varying is not the length, it is the mass. If they keep the mass constant, if they put a particular amount of mass on the rule and they say you should make sure it oscillates, then you can use, that's my method, the one I released for mechanics, T equal to 2 pi root L over G. Do you understand? But if they don't, if what they are varying is the mass, then you have to conduct the experiment. I believe I am clear. Okay? I am not telling you that this is a sure, I'm not telling you that this is something that it must come out. No, I am not. Okay? I'm just saying that it has a very high percentage of what is coming out like that. But even if it doesn't, and mass is introduced into it, I can't give you something I'm not sure of. If not, I would have analyzed one of the formulas and everything. I can't give you something I'm not sure of. And that is why I advise that you conduct the experiment and get your readings instead. The most important thing is that your graph is what? Is well plotted. All right? Now we have a graph. I want to analyze how your graph should be. Because no matter the method of getting your reading, it all boils down to your graph. If you have an accurate reading and your graph is not accurate, then you have just done nothing, because your graph, the results from your graph will determine how accurate your results are. So it all boils down to your graph. You should know how to plot your graph. Now, the first thing you have to know about the first rule of plotting WAEC graph is that your graph must cover at least 70% of your graph booklet, of your graph surface. Like if you are seeing the graph here, you will notice that everything is there's an area where the graph is covering. The graph book, the graph sheet is just like that. Then your graph diagram should cover at least 70% of the graph book. So no matter the scale you use, no matter the counting system, how you counted for the vertical and the horizontal axis, you make sure that it is covering at least 70%. Okay? For example, let me say I count tick line. You know, you see all those tick lines. I count it from down. Okay? If I start from the fourth line, when you're counting from down. 1, 2, 3, 4. The fourth line from when you're counting from down. Okay, the bottom of the graph sheet. If I start my graph from the fourth line, counting from the bottom, then an up, and it covers from that fourth line to the top of the of the graph book, I am okay. If it covers from the third, from the fourth, from the third, from the second, from the first, it's okay. You understand? So you choose a counting system that is going to make sure going to ensure that your graph book is covered, at least 70% of it. Your graph sheets, your graph surface, the Cartesian plane is covered. Not that your graph starts maybe on the maybe seventh line and it goes to the top. That is not advisable, please. Okay. So that's the first thing you have to consider. Your graph, no matter what, your graph will cover at least 70% of your graph book. Okay. Another thing is your title. All graph must have a title. If you miss the title of a graph, then you are wrong. Are you getting it? All graph must have a title. Okay. Maybe they say you should plot t square on the vertical axis and L on the horizontal axis. Okay. You know how to do that. Okay. All right. T square on the vertical axis and and L on the horizontal axis. So your title will not be what? T square is graph of T square against L. Graph of what you have on the vertical axis against what you have on the horizontal axis. Graph of T square against L. Okay. If what they say you plot on the vertical axis is maybe a parameter m against maybe n square, okay, so now what? Graph of m against n. All right, then you move forward to what? To drawing your axis. Okay, drawing your axis involves drawing the vertical axis as well as the horizontal axis. It also involves making sure that the scale you choose. When I say scale, I mean your counting system. Okay? When I say scale, I mean what? Your counting system. What counting system are you using? Are you using 0, 2, 4, 6, 8, 10? Are you getting it? Are you using 0, 5, 10, 15, 20, 25? Are you using 0.1, 0.2, 0.3, 0.4? Are you using 0.2, 0.4, 0.6, 0.8? Are you getting it? Okay? Do you understand? So that is the question. So which one are you using? Now, the one you will use, must make sure that what the graph covers at least 70% of the graph, and that is determined whether your graph covers 70% or not is determined by the vertical axis. It is the vertical axis that means that what your counting system on vertical axis, that what shows whether your graph covers at least 70% or not. You understand? So that is just it. You try as much as possible to make sure that your graph covers at least 70%. And when you choose your scale, for example, maybe the highest in the vertical axis is 70. And if you look at it, if you look at this graph now, we have like how many thick lines? We have, I don't count the one at the top, at the bottom, okay? So I will say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 thick lines, okay? So if I take my that first one as my origin, that is 0, okay? That first thick line as 0, okay? And I start counting. Maybe I say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. You see, it didn't get to that 70, which is the highest. So I will now adjust it a little bit, okay? To know if I will what? If I will able to get 70. But please take note, as a matter of experience, you don't just use any counting system. Try to use a factor of what? 1, 2, or 5. I repeat, try to use a factor of 1, 2, or 5. What do I mean by that? If you are using a factor of 1, it will be 1, 2, 3, 4. Are you getting it? If you are using a factor of 2, 2, 4, 6, 8, 10. If you are using a factor of 5, 5, 10, 15, 20. Are you getting it? You can also use 10, 20, 30. That is also a factor of 1. Okay, 10, 20, 30, 40. Okay, you can also use 20, 40, 60. That is a factor of what? 20. I mean, that is a factor of 2. You can also use 50, 100. Are you getting it? And so on and so forth. That is a factor of 5 too. Also, another factor of 1, another example of factor of 1 is 0.1, 0.2, 0.3, 0.4, 0.5, and so on and so forth. Okay, another example of factor of 5 is 0.5, 1, 1.5, 2, 2.5, 3. Are you getting it? Okay, another factor of 1 is 0.01, 0. As the case may be. Okay, depending on what you have on your vertical axis. Are you getting it? So you try to adjust the vertical axis so that it will contain the highest you have on the what? On the graph. And at the same time, it will cover at least 70% of your graph book. Are you getting it now? Do you get it? So if the highest is 70, I use 5. I find out that it is not what? It's not equal. Okay? I use 5, 10. I will now use 10, 20, 30. I stopped at 60. And you find out that I'm going to 70. So I use 10, 20, 30, 40. If I use 10, 20, 30, 40, I find out that it will enter. And that is the scale I will use. That is the counting system. Okay, if I use 10, 20, 30 as my counting system, that means from one tick line to the next tick line is 10 units. Okay, it is 10 units. And the units there is represented by the units you are plotting on the vertical axis. For example, if you are plotting t square on the vertical axis, and t, the unit for t is seconds. So that unit for this thing will not be what? Second square. So, which means from one tick line to the next tick line is what? 10 seconds square. And if you measure using your meter rule, if you use your ruler, that one that you people call ruler, okay, you measure it. You measure using the centimeter edge and check the length from one tick line to the next. You find out that it's what? It is 2 centimeters. Try it. You will find out that it is what? 2 centimeters. That means we are looking at what? That means in your graph, 2 centimeters is representing 10 units. So your scale is what? It will not be what? 2 centimeters to 10 units. Another thing that is very important is your scale. Your scale is very, very important. Okay? So if you put your scale, your vertical axis, your counting system, when you search which counting system will be best, okay, you choose 10. It's not what? 2 centimeters to 10 units. If when you choose and your counting system is what? 0.2. Okay, 0.2, like 0, 0.2, 0.4, 0.6. Then your scale will not be what? 2 centimeters to 0.2 units. Or 2 centimeters to 0.2 second square. If it is length, now it will be 2 centimeters to what? 0.2 centimeter. Do you understand? Do you get it? Or meter, as the case may be. All right? Then you plot it. Another thing is now, when you now discover your counting system, you now know where what? Your vertical line will be. Are you getting it? Then, if you know where, if you know, you will know where your zero line for your vertical axis will be. Then to determine where your zero line for your horizontal axis will be, you use the same method to test the horizontal axis. What do they say you plot for the horizontal axis? And what is that, the highest value of that thing they say you should plot? What is the highest value according to the table of values? Now, when you get that, you'll be able to what? To signify, to identify what counting system you would use so that it will cover, this time around is the width you are looking at. Are you getting it? It will cover from the zero and everything. Okay? You choose it. Anyone, if you use you start with just start with any counting system. If it doesn't contain it, okay, if it is too small, maybe you started from the first vertical tick line, I guess is going, and then you find out that with your counting system, you arrived too early at the highest value. That means the highest value should be towards the middle or less than the middle. That is not best. The best thing to do is to what? Is to decrease your counting system so that it will extend. And when you are decreasing it, try to maintain the factor of 1, 2, and 5. Do you get it? Now, the next thing is to what? Is to know what will be the length of the smallest graduation. Okay, that is the next thing to do. The length of the smallest graduation depends on your what? On the length from what? From the value from one tick line to the next. Okay, so, and that is how you do things. Okay,